Here now we are going to answer the highlighted question here, Roman numeral 3, which reads, what are the coordinates of the point of intersection of the line and the parabola? Alright, so looking at the diagram now, we have two lines, a straight line and a curved line, or the parabola, and they have 2 points in which they are intersecting. So we are going to look at the points of intersection now. First of all, let's get the equations for the two lines, the straight line equation and the parabola equation. If you don't know how we got the equations, you can go to the first two videos where we found the equations of the straight line and the parabola. First step is to find the x points of intersection, because there are two different places that the lines meet each other. There are going to be two x points of intersection. Okay, we're going to use this equation now. The two different equations, the straight line equation as well as the parabola equation. Okay, so y is equal to the straight line, y is equal to 3 over 5x minus 3, and then for the parabola it's 3 over 5x squared minus 18 over 5. Okay, and both of them are equal to y, so that means they're equal to each other, so we have them in this form now. Let's move the equation, this equation here, we move it on to the left side, so it becomes just one equation, which is equal to 0. The fractions here, we are going to simplify the fractions before we do anything, just to make it easier. So to simplify we multiply by 5. Looking at 3x squared, the numbers 3, 21 and 30, they are all multiples of 3. So we divide it all by 3 just to make it simpler, and then we have this equation here, which we then need to factorize. Now looking at these numbers, let's find out what two numbers when we multiply will give us positive 10, and when we add will give us negative 7. Okay, when we look at it, it should be negative 2 and negative 5 when we multiply would give us 10, and negative 2 minus negative 5 would give us negative 7. So x minus 5 is equal to 0, and then x is equal to 5. Now we move on to the second one. X minus 2 is equal to 0, so we move it over to the other side. X is equal to 2. So those are our 2 points of intersection at x. So for the value of y, we are going to use this equation. Y is equal to 3 over 5x minus 3, which is the equation of the straight line. We also have the parabola equation, which we could use, but the equation of the straight line is simpler, so we are using the equation of the straight line in the second step. Now we use x is equal to 5 to do the first, or find the first intersection. After all the calculation, we have y is equal to 0, and that is when x is equal to 5. That is for one intersection. Now we find the coordinates for the next intersection. We use the same equation. This time we use x is equal to 2. We substitute 2 into this equation here. So now we have y is equal to 3 on 5 multiplied by 2 minus 3. We have now 6 on 5 minus 3. We want that to have common denominators, so it's easier for us to do calculations. So we now have 6 on 5 minus 15 on 5, which is the same as 3. So 15 on 5 is just the same as the whole number 3. And now we have y is equal to negative 9 on 5, which is also equal to y is equal to negative 1.8. With that, you will notice that the first two coordinates, 5 and 0, can easily be identified within the diagram itself as a point of intersection.